For example, I will not solve all question. Just I will show again. Same technique, reference point. Okay. And push down by 0.1 meter. If you take your reference point from here, you don't need to calculate this part. You don't need to calculate potential energy of this H part. And then just you need to find what maximum height above the point of release. Does it rise? Okay, perfect. When it comes to here, there is just be careful potential energy coming from spring, say PS. I will ignore potential energy, and at that point my velocity is 0 because it says similar thing. Okay, it's compressed. Just I will have potential spring, and finally it will release with some velocity. So please be careful. You have to say this. Oops, sorry, I have to find all potential energy coming from spring convert to kinetic energy. And oops, sorry, don't forget here. Yes, sorry, I don't have any potential energy because I will calculate from here, and it will release from here. This mass will going up and then come down. It's asking what's maximum height from here above the release point. Release point is here. Just you need to calculate this part. Okay, even you can say kinetic energy, all kinetic energy must convert to potential energy because it's here my velocity will be 0. Okay, I just solve quickly. You can make all math parts by yourself. Just there is some energy conversion. This potential energy coming from spring convert to kinetic energy because it's released with some velocity, and then I have to forget spring part because this mass is leaves from spring with some velocity, and then this all kinetic energy convert to potential energy until here. Just you need to write that part, and then you can calculate the height, maximum height. Maximum height mean its maximum height, your velocity will be 0. So I don't take kinetic energy at this point because it will be 0. Okay. Continue with different question. Okay, you can see there is like this system, and what's saying? Okay, it gives some mass information, K information. Incline is frictionless, very nice. The 20 kilogram block is pulled by 20 centimeters. Okay. This one comes to here. And this part is 20 centimeters. Right? When this block moves by 10 centimeter, this 30 kilogram mass block comes to that part. And it says, what it says, sorry. The block is 40 centimeter above floor. So there's 20 centimeter here. You can add 20 centimeter here. Perfect. And it's released from rest. Find the speed. My first velocity, initial velocity is 0. K initial will be 0. Okay, perfect. Find the speed of each block when the when these which ones yes, this block is 20 centimeter. It means it's come to same position above floor. That is when spring is unstretched. Okay. Say this is my again reference point. And my potential energy is 0. Okay, just I am thinking, yes. How can I write? Okay, so at this point it is 0. And can I say, can I write like that? K initial plus P initial equal. If there's some spring, I have to add that part. P as initial, K final, P final, and if there is some spring potential energy, I have to add that part. K initial is 0 because it says it is rest. And is there any other information? It is asking, okay, velocity. What do you think about potential energy? What do you think about potential energy at initial? Okay, this one is here at reference point. So can I say its potential is 0? Yes, you can say it is 0 because now there isn't any height. There isn't any elevation. So you can say that part is 0. But don't forget there are 2 masses here. I have to add that one. Sorry, I forgot second one. Oops, I have to add that part. Sorry, come on. Yes, we have to say all things. Okay, potential energy. I will change my color. Okay. For say this is M1 and say this is M2. And maybe I can write like that. M1G, I don't know if it's say H1 initial and M2G H2 initial. If there's spring potential energy, is there any? Because yes, we have. It's stretched until here. So I have to add that one. 1 over K x square, which is 20 centimeter. You need to convert that part. And I don't know final kinetic energy. I will write. There is velocity here. Be careful that one. What do you think about their velocity? It's come to here. Say this is V1 and second one is V2. Of course, they connect each other. Just assume, just try to remember Edward machine. Their velocity is same because they attach each other. One of them cannot be cannot has more speed. It's not possible. Otherwise, this machine doesn't work. So, okay, I will write this one and for second part, V square, okay. Also, I will add potential, but I want to come spring one. When it comes to here, it is unstretched because it's already say at question. It says at first position, the spring is unattached and system is shown like that. The system, this must return, and of course, the spring is not stretched. So my spring is my potential energy coming for spring part will be 0. Okay, I have to add potential. Look at M1. I have to calculate this part because it come back to here. I don't know this one. And say this is final part. I have to calculate that one. M1GH, what was it? H1F plus, what do you think about M2? It's come back to same position. I mean, reference point. So M2G will be 0 because I don't care this part. My new reference point is here. Okay. I think we can calculate everything. Okay. What do you think about H1 initial and H1 final? Are they equal each other? Look at here. H1 initial equal H1 final. Yes. Oh, sorry, not this one. Not here. I'm confused. Okay, look at here. At first point, it comes to here. So my reference point will be 0. Just I am looking for this formula again. It will be 0 because H1 initial will be 0 because of reference point. Look at that one part. It was here. It's new ground state. It will be 0. My H2, yes, you have to take that part. It will be 20 centimeter, but be careful. If you need to convert this say H2 initial 20 centimeter must be converted to meter or to 0.2 meter. X is same. It says the spring is stretched. And you have to take that one as well. Just you have to put all the information here. M2 is what's M2? M2 is 30 kilogram. 10. What's the H2? H2 is 0.2 plus 1 over K is what's K? I don't know. What was it? I know X is 0.2 squared. Can you write? Okay. Can I say M1 is 20 kilogram B square and that part just I am writing here plus M1 is 20 kilogram and G is 10. I forgot to find H1F. What's the H1F? Okay, it is easy to find. How can you calculate this 20 centimeter? Just I will write here This is 20 centimeter. And this is again same incline. I can find here what I call it, that part H1 final. H1 final will be say, please convert this one to meter. 0.2 meter. And sin 30. Just you need to write that part. Multiply sin 30. And finally, if you calculate, this is math part, I don't want to waste my time. Finally, your velocity, I can write like that, sorry, 1.25 ms. Maybe I can show again quickly. Just it start from here and it come to that part. I am talking about M1 mass. And if we talk about the second part, second mass, firstly it start from here. This is my initial part, and it come back to same position, which is releasing part. Okay, it means there isn't any stretching here when it come back to when M2 comes back. Okay, I hope you understand how can I take some reference point. Even you can say, okay, say this is 20 centimeter, this is 20 centimeter. Even you can calculate its potential energy, but then you will cancel that part. It is meaningless to calculate this part. Okay, I hope you understand this question. I know it is maybe because of my drawing, I create confusing on your brain. If you have some question about it, please ask me.